so for anyone missing out on class this week, so now they ask us, I'm going to do this with a highlighter because it's kind of hard to see. They ask us for the length of the diagonal of the box. So actually, for drawing purposes, I'm going to draw it from this vertex down to this vertex. So we're saying from the back corner of the box, so the front corner of the box, how long is that? Now, we know just based off reasoning, is that going to be more or less than 60? More, because like if you've ever tried to put anything in a box, if it doesn't fit this way, you turn it diagonal and it fits a little bit easier. Now, can I jump right to finding that pink length? No. What do we need to do first? We need to find the hypotenuse of the base face, right? So base is always tough because we can actually make anything the base. But if we find the hypotenuse beneath, like we're going to make a new two-dimensional shape. So we're going to have the two-dimensional right triangle that comes from here. But then we're also going to stand up a two-dimensional right triangle here. So the pink, the blue, and the green will all come together to be its new right triangle, realizing that's in the back and it comes to the front. So first we look at our blue triangle being $60, $60, and something else. What's 6 times 6? 36. Put 2 zeros on it. Square root of 3,600, right? What is the square root of 3,600? Oh, sorry, not 3,600. Who's got it? What is it actually? Square root of... What number goes here? Under the radical. 7,200. Sorry, I forgot to double it. I did the a squared. Oh, thank you very much. I did the a squared, just forgot to double it. So now square root of 7,200, 84-ish, right? Go ahead and keep 2 of those decimal places, or just work with square root of 7,200 if you want. So I would write down both. I would write down radical 7,200, and I would write down the 84.85.
Well, you don't have to do that. Because you just use it because you square it after.
I agree. This is, as we go through the solution process, this is what we normally do. Like, our normal tendency is to solve it, right? So that's why I'm writing this down. But keep this because it's easier to use this. Because then when you square 84.85, I agree with you. Do not disagree with you at all. So what's our green leg? What's our green leg? 60, right? So now we've got 60 from the green leg. We've got, I'm going to get yelled at because I'm about to say 84.85. Or the square root of 7,200 as our blue leg, and then our pink leg, the hypotenuse that cuts through the third dimension of this. So a squared plus b squared, this is why Alina yelled at me. When we square 84.85, we get 7,200, right? So we're just going to do 7,200 plus 3,600 from 60 squared. 10,800. So this will be the square root, and sorry if you can't see this, let me know. I know I'm writing in pencil. I'm going to grab a pen, wherever it is. Square root of a squared plus b squared. So the 7,200 came from here. plus 3,600 came from the 60. So it is square root of 10,800. Now guys, if I tell you Amazon has computers doing this all the time, who can tell me what I mean? Why would Amazon have computers doing this all the time? What'd you say, Caitlin? Okay, give me more. We need to minimize, now what would minimize shipping costs? Why? What is the box made out of? Yeah, we want to use the least amount of cardboard possible. Don't know. Because I'm trying to multitask. Thank you. It's actually just 103.9, right? Thank you, Alina. So in a cube box, right, we could actually fit in a box that is 60 by 60 by 60 cube, you could actually fit an item that is 103.9 whatever that long. So here I think they gave us that, and they don't give us units. But that's kind of pointless to waste all that space vertically. Right, so we start to look at boxes that one measurement is smaller so that we can start to minimize the amount of cardboard that we use. This is when you can't trust what things look like. So if you look at this box, the picture kind of looks weird because this is 2, but it looks pretty big. So throw a quick sketch of this on your paper or sketch the two-dimensional pieces that you need as you need them. Sorry, I see people in the back of the room struggling because those numbers are kind of small. Let me make this as big as I can. What? I said let me make this as big as I can. Sorry, I realized if I didn't teach this today, I wouldn't get to teach it at all because you guys would all learn it on your own between now and then. I wonder, like with most math, if there's multiple ways to do this. Right. I'm trying to find a rectangular sheet. Now, as long as you can remember that what things look like doesn't matter, and the math is what matters, you can really draw whatever you want. So because I have a little shapes template, I use my shapes template to draw a perfect rectangle, and then another perfect rectangle of the same size, and then I just give it the dimensions that I need to. Still, we know that what we're solving goes from the back to the front, so it's going to take this line, which means before we get to doing that, we need to solve essentially like its shadow, right? We need to solve what is the distance beneath it, and then we can incorporate this vertical. Because when you're drawing the picture, copy the important dimensions to the other pieces that we're going to use. So the first two-dimensional triangle that we're going to use is going to use what legs? 8 and 2, right? So we're going to do 8. I can do this appropriately if I want. 7, 8, if my pen would work. And 2, if I actually make this look like it's supposed to. like on my graph paper. Square root of 68. Should we put this in decimal form or leave it in radical form? Leave it in radical form seems to make more sense. So again, this is the blue side that I drew in my picture. Meaning that now the two-dimensional triangle that I'm going to use is that square root 68 and what leg? Yeah, square root 68 and 5. So then get the pink distance from the back corner to the front corner diagonally. So a squared plus b squared, right? We're going to get 25 from squaring this, but then 68, because we just really get rid of the square root. So this will be square root of 68 plus 25. Which is how much? It was radical what? Radical 93, which then reduces out to be approximately 9.64. Does that technique for finding the diagonal hypotenuse make sense? / what questions do you have? Mara, is that a hand or was that just stretching? I think that's a fun technique of like how to visually break up a three-dimensional shape into different two-dimensional pieces. So I felt like I would rather teach it in 10 minutes than make you guys go watch the con video. So now spend the last, whatever you got, 10 minutes-ish, not even, 5 minutes-ish of class. Spend the last time that we got working on that unit test. Yes. Do you have it in e-hall pass? If you do not get done with the unit test, I would like you to try to get that done today if you could, like for homework or whatever you want to call it, or tomorrow on your at-home day, but I would prioritize watching the inauguration if I was you. Huh? The what? Oh, I don't care. I don't give two shakes of a lamb's tail about Donald Trump.